Hello, everybody. Welcome. So a colleague of mine recently asked me, Labhesh, what is the difference between normal software engineering and artificial intelligence? And as I thought about it, in the normal coding world, in the normal software engineering world, we understand the needs of the business, and we write code to directly execute those requests. So we come up with the rules, we actually codify the rules, and when new scenarios, new data come in, we come up with results. In AI, we are mostly working on coding up a learning strategy, and the job of this learning strategy is to look at historical data, scenarios, things that have already happened, where we know what the results are, and the learning algorithm is trying to figure out the rules that govern the game. So here, we are trying to find the rules, and when new scenarios, new data comes in, we come up with the predictions. What it boils down to is machines crunching numbers super fast and trying to find latent patterns within the data. Humans have a hard time matching that speed, but humans have something else. Intuition can be thought of as a brain process that allows us to make decisions without consciously and analytically acting upon those. And it takes a long time to develop intuition in any field. Experts at this point are able to scientifically measure intuition. So in one experiment, what they did is they showed certain combinations on a chessboard to grandmasters and amateurs, and then they went ahead and studied the brain activity using fMRI. Now, these combinations were shown to both groups for less than a second, just to make sure that the conscious analytical reasoning doesn't kick in. And what they saw is that in the experts, a certain part of the brain called precuneus lights up. And precuneus is known to be responsible for visuospatial processing, which is basically pattern matching. So humans have this ability, or rather, experts have this ability to look at a situation and right away intuit about it. And they also saw that there was a huge correlation between the lighting of the precuneus and the next best move that the experts or the amateurs were trying to make. What about putting these two things together? Anybody out here heard of cyborg chess? So cyborg chess, or centaur chess, this was an international chess tournament that was held a few years ago, where the rules of the game allowed any combinations of human and machine. So team combinations included supercomputers, people with supercomputers, grandmasters with laptops, but the winning team consisted of 2 amateurs with 3 just average-sized, average-powered laptops. What ended up winning was not their superior chess ability or superior programming ability, but the process that they figured out with which to work with the machines. This brings me to augmented intelligence. Augmented intelligence is a conceptualization of AI that helps highly trained knowledge workers. The AI layer complements the knowledge workers by automating away or dramatically reducing the time it takes for them to do low-value tasks so that the trained individuals can focus on the high-value tasks at hand. But the decision, the final decision, always rests in the hand of the human. Now, the question arises as to how do we decide whether we want to go for a pure unassisted AI implementation or an augmented intelligence implementation. And when we look at the use cases, a few things jump up. The first is, when you're looking at pure AI, unassisted AI implementation, usually the velocity on volume of data is really, really high. We just don't have the ability to have a human in the loop. The individual inferences or results from an AI model are not that critical. What moves the needle in these cases are aggregates. And interestingly, in a lot of these use cases, the motivation for adversarial attacks is low. So the motivation for a bad actor coming in and trying to mess around with the system is low. And if they do end up doing an adversarial attack, the cost to the enterprise is low enough. Some examples. Product recommendations is the poster child of unassisted AI. When you buy product X, you get recommended product Y. Now, every now and then, the recommendations are a little bit weird, but you don't really care about it. Life goes on. Does it move the needle? Obviously, it does. Amazon is probably the most valuable company in the world today. Depends on the day. But here also, the aggregates are what are important. Nobody is sitting down and looking at each and every result. Machine translation for non-critical use cases, like colloquial use cases, is another super helpful and successful example of unassisted AI. Now, nobody is using free from machine translation for air traffic control systems yet, but it gets the job done for the normal non-critical use case. Sentiment analysis involves AI models looking at text and trying to figure out the positive, negative, and neutral sentiment towards a certain brand or a product feature. It would not be possible to fathom putting a human in the loop out here, just because the velocity of the incoming tweets and posts whenever a brand launches a new campaign or a product is so high. Here, again, aggregates are important. Every now and then you get a misclassification if there is sarcasm or somebody saying things in a very weird language structure, but that's not really important. Some examples where we have seen a lot of research, but we have not really seen things in the hands of everyday users. The first is self-driving cars. The cost to the enterprise out here is just really, really high. Aggregates are important here, but you do care about the tail. I don't see any dads kissing their children off to school in a Waymo car yet, just because the cost is too high of getting things wrong. There was a recent Stanford algorithm that is able to look at chest X-rays and screen simultaneously for 14 pathologies. In 10 of these, the algorithm performs better than a panel of radiologists. In 3 of them, it performs worse. And in the last one, it performs better. But here also, the risk and the liability involved with having a completely unassisted decision-based workflow is just too high. NLP and AI systems today have the ability to go through hundreds of thousands of reports in less than a second and come up with portfolio recommendations. But banks that have went ahead and implemented this use case still don't flow all the recommendations directly to their high net worth clients. When you get it wrong, the risk is too high for you to be losing the client. Fraud detection is another needle in the haystack problem, where fraudsters of today are just highly skilled combatants, and they are engaged in ever-changing devious schemes. Here, most of the unassisted AI models would come up with a lot of high false positive rates, where you will end up pissing off honest users, and it's going to cause, you'll see a hit in your top line. When you look at your use case, the first thing that you should look at is, okay, well, are there certain criteria that if we meet them, we should be looking more towards assisted AI? The first one of them is you cannot afford to be wrong. If your use case demands that, well, you need to be right pretty much all the time, and aggregates are important, but so are the individual results, you want to be using augmented intelligence. In a lot of data sets, what you will see is that a lot of the volume is in just one fraction of the data. But you still want to be coming up with the right answers for the tail, where you have sparse data. If you have that kind of a scenario in your data set, you want to think about augmented intelligence. If your use case involves somebody motivated, if there is inbuilt motivation for somebody to come in and try to play around and mess around with your system, you want to probably have a human in the loop. If you already have experts where you see that every now and then their insight just blinds you, they have built up intuition over the years, you want to see how you can still leverage that and not completely get them out of the loop. We touched on explainability in the previous panel. Explainability is about an AI model letting you know the answer and also giving you the reason why it came up with the answer. And explainability is a very active area of research in AI. There is progress happening, but it's still early days. If, for regulatory reasons, you have to come up with explanations for inferences for your use case, augmented intelligence is the way to go. And your use case is something that doesn't necessarily require an answer within few milliseconds. And a lot of the times, your rest of the enterprise workflow is not geared towards taking answers from a AI model super fast. Think about sending recommendations to clients in a financial services setting. You don't need to be sending them a recommendation every millisecond. And this brings me to a real-life scenario from work. Jumio is in the business of establishing remote trust and identity. Financial institutions use us to make sure that fraudulent users don't start opening accounts randomly on their sites, and to comply with KYC and AML requirements. How do we do this? Well, we use a mix of AI and ID experts who work together to make sure that a state-issued ID, such as a passport or a driver's license, is very quickly authenticated through a simple API call. Now, why did we go for augmented intelligence? Well, if we go through the same set of criteria, account takeovers are expensive. So if we get things wrong, the cost to the customer is super high. We do care about the tail. We support about 4,000 different IDs, and probably 20% of the IDs have most of the volume. But we want to be able to tell our customers that even if some user from a remote geolocation wants to start an account and become their customer, we are going to help them convert that stranger into a customer. Is there a chance for adversarial attack? Of course. This is basically the name of the game out here. And we are still blinded by how much of human intuition comes into play. And just a story from the trenches on this. A while ago, we started seeing a lot of IDs coming from a certain country, and the country is going to be unnamed, where the name on the ID, the country name, was misspelled. And after the AI system started flagging these IDs as fraudulent, the experts looked at this and they are like, no fraudster worth her salt is going to be making this mistake so many times. They contacted the regulatory authorities and they figured out that the country had released a whole batch of IDs into the public with the name of the country spelled wrong. But that was a completely authentic ID. And we see examples like that on a daily basis. For GDPR reasons, we need to be able to explain our results. When we reject an ID, we need to tell our business customer why we rejected that ID, because if their user asks them, they need to be able to tell them for regulatory reasons. And user onboarding and some of these use cases are quasi-real-time. The thing that has transformed over the last few years is instead of going to the bank and spending half a day trying to open an account, you are now doing it from home. It still takes a few minutes, but the expectation is not that you are going to have an account open within less than a second. So if it takes a few seconds for us to verify the ID, it's all good. And when an ID comes into the system, all the AI models look at the ID, they come up with scores, they come up with data, and all these scores and data is presented to the expert through an interface which is akin to Iron Man's helmet. You see they see all the data out there, and then they go ahead and make the final decision. So AI alleviates the entire busy work, and the human completes the loop. In summary, you want to study your use case, and if it matches some of the criteria that we talked about, quasi-real-time, explainability needed, the cost of getting the answer is too high. You already have experts where they have built in a lot of intuition. You want to look at augmented intelligence. And I do believe at some point in time, AI might stand for artificial intuition, but till that happens, I think we will probably maximize enterprise value by augmenting our experts rather than replacing them. Thank you.